This video in verse programming is going to change your life. It's all about classes and object-oriented programming and inheritance. And if you want to build amazing games, you have to learn this. No going back, no skipping. Do this right now. Lesson 8, all about classes. Let's go ahead and get started. You can create a new project or continue as we've been continuing. And what I'm going to do is create a new verse file in my Verse Explorer. Create new verse file, and we're going to call this one lesson 08. This is classes, okay? All right, a class is a way to just classify code, to put it in an object. Think of it like this. Okay, a car factory that makes cars or vehicles, all right? They make a sedan, they make a truck, they make a Jeep, whatever. Now, these are all vehicles that drive on the ground and have similar features, but they also have differences, right? A sedan is different than an SUV. They have different features. And so what we do in code is we work with classes to make our life easier, because what a lot of new people do is they grab a file like this and they copy and they paste and they copy and they paste, and the bugs start racking up, and we want to start thinking in terms of design. I find that artists really enjoy and appreciate when they start learning to code classes and object-oriented programming, because it just makes sense. You create a blueprint for a car, and then you make the car. You make a blueprint for a truck, and then you make the truck. So what we're doing is we're creating blueprints, and then I'll show you how to create those blueprints with classes, okay? It'll make sense as you start to watch. So in our game, what I want to do is I want to have some type of, let's say, moving platform. But I want these platforms destructible. Later, I also want to have like a pet, like a player can have a pet that follows them around. But I also want the pet destructible. I want it to have life too. And so what I could do is I could start coding in here. You know, I could say var pet HP of type int equals 100. I could say var platform HP of type int equals 100. But I feel like I'm really starting to duplicate code, and this doesn't make a whole lot of sense. So here is where classes come in. And you've seen it already a little bit before here in the class in our files we're inheriting from Creative Device. When we have an object inside of these parentheses on a class, it means that we are inheriting features from another class, or we are implementing an interface, which is similar to a class. It's a set of rules that you're implementing here. So if I control click on Creative Device, you're going to see that this is a class that has features in it, or rather it has functions that are publicly available. And those are also available to me in the code. So on begin, we are overriding the function that is in the on begin in the Creative Device. Oh, it's not magical, right? It's coming from an ancestor. It's being passed down to us here. So let's go ahead and create our very first class. What we're going to do is above this class, you could also do this in a separate file if you want. I'm going to create a class called pawn, equals class. The idea of a pawn is it's just something that can move around and perhaps take damage. It might be a platform, it might be a dragon, it might be a robot, whatever. Okay? So var total HP of type int equals 100. Var current HP of type int equals 100. Okay? What we were doing just before, kind of, except we're going to put it here in this class. Now, what if I want to take damage on this pawn? Well, I can create a method called take damage, and we pass in the damage points of type int void equals, and then what would we want to do? Well, we would simply say set current HP minus equal damage points. Okay, so here in our class for our pawn, this is where we're writing the logic. In our game development, in our devices, that's where we want to write the logic for the game itself. But objects that are in the game, they should manage their own code. This is really important. We are modularizing our application. A game manager, okay, it's like a service. It manages our game. And then we have submodules, or these classes, these objects in the game that should manage their own code. I should not have to tell a platform where to move or how to move. I could tell it where to move, just not how to move. It should know how to do that already, or how to take damage. okay? Now, I know I'm talking a lot, but it's important that you listen to all the words that I'm saying here, because if you design your code right, your games will have less bugs and be so much more easier to navigate and quicker to deploy and to build. So let's do a heal function or method. Say heal points. Remember, these are actually called methods unless they're publicly outside of the class, in which they're typically called a function, but it really doesn't matter. Okay, we're gonna say heal and set current HP plus equals heal points, okay? So you've seen this before. We're just healing and taking damage. Pretty cool. And just for fun, what I'm gonna do is have another method here called isAlive, and then I'm gonna say void equals, and in this case here, we're gonna say decides, because when we call this, I want it to be able to fail if they're not alive, okay? And I'm going to say if current HP is greater than 0, we're just going to say true. And remember, in verse, this equals means we're assigning it an expression. It's waiting for a value. So you don't have to say return per se. It's just expecting a value, okay? And when you use decides, if you return false, it's actually going to fail. So what I'm going to do is say else false, like so, isAlive. So these are some useful methods here that we can put on a pawn class or a pet or whatever. Pretty cool. Now, how do we actually use this in a game? So what we do is here in onBegin, I could create my pawn, right? I could say some pawn colon equals, and we just say pawn, like so. And what it's just done is it's created a new instance of this class, and so I could say some pawn dot take damage, let's say 10.0 or 10 if it's an integer. Now this is fun, and we could go through a loop and make a bunch of these, and already you have improved your code and made it so much better than if you weren't using classes. But this isn't the true power of object-oriented programming. Let's go ahead and demonstrate that now. We talked about a platform. So let's make a platform. Think a moving platform, okay? What we're going to do is I'm going to make another class called platform, colon equals class. But this time, it's going to inherit from pawn, okay? It's going to inherit from pawn. So this pawn class, we are inheriting from it, just like our lesson 08 device is inheriting from creative device. So what that means is it's going to have these functions available to it, okay? Now, what I want to do is think about what is a platform supposed to do. Well, a platform, in our game, it needs the actual prop, okay? The Fortnite prop. It needs a starting position, and it's going to need an ending position, okay? So we can add those in here. We can say platform prop of type creative prop equals creative prop, like so. We can say starting position of type vector3 equals vector3, because positions use vectors, and we'll need to import the spatial math module for that, like so. Okay, so that's our starting position, and let's do our ending position. Is a vector3, and create a new vector3 right here. So here's our platform. Okay, now just for fun, let's just create a new platform. Say new platform, okay, colon equals, and then I can just say platform. Okay, in this case here, we've got some empty, these have already been instantiated, so we don't necessarily have to pass anything into it right now. So what I could do is I could say new platform dot take damage. And check this out. Some pawn dot take damage and new platform dot take damage. So now things are getting interesting, right? Because I've got a different type of class, but I can still call the parent functions on it. I did not have to rewrite code. Oh my gosh, right? We didn't have to write a damage code for our pawn, a damage code for a platform. We get to share the same code. That means less bugs, right? And you write code faster. That's why I said you build faster if you do it this way, because you're not taking more time to do the same thing over and over. And now this is where it gets fun, because we can add functionality to our platform, right? So what we can do is we can make a move method like so, and say void equals, and then we can actually move our platform here. And one thing to note is, as I'm looking at this code here, I'm realizing I should probably have only my methods publicly available, but not my properties. Because here's the deal, look at this, total HP, current HP. If I'm down here and I say new platform dot current HP equals, let's say 1, and I set that, I'm manipulating data from a class directly, which is not good. The reason why this is not good is because imagine we have 50 code files, a team of 10, and everyone is working in the code, and all of a sudden everyone just starts changing our data. Now we have no idea what's happening and where, and when we have bugs, who knows where it's coming from? This could have been changed 100 times. This is really bad. We need to employ what's called data encapsulation. And that's gonna protect our data from bad things happening. We want everything that changes data to happen inside of our class. We do not want outside influences changing our data. We want to control it. So what I want to do before we move on to further enhancing our other classes and subclasses is I want to change the privacy of these variables, these properties. So I'm going to enter the keyword private here, this private specifier. Now, if I click save, now you're going to see a red squiggly, invalid access. I can't change it. I can't break the rules. You're a brand new developer on your team who's like, I'm just going to change this around and, put some value in here because I can't figure out how to do it the right way. Well, now they can't do that because you've been a good programmer. So what we're going to do is make our properties private in almost all cases. And then what we do is we make our methods public. Now they're public by default, but I like to specify the public keyword on these to make sure that it's very clear. Okay, so these are now public. These are the methods that we're going to change. Okay, because what would happen if someone just said, added 1,000 HP on here? Well, we only have 100, right? So in here, where it says heal, we could clamp this that it's never more than 100. But if you let somebody else outside of your class here do that, they can put 1,000 or 10,000. Okay, so this is why we encapsulate our data. This is why we protect our data. It's called data protecting, data encapsulation. Okay. In other languages, it's called creating getters and setters and things like that. That's kind of what we're doing here. So we could do the same thing here. I'll let you do that on your own now that you understand it. So we have this move function, okay? We'll make this public just to kind of keep the tradition here of having our public functions. And imagine now if a platform should move back and forth continuously, okay? So what I'm going to do in here is just write some simple code. We're going to loop like so. And we're going to say if, and let's make sure that our prop is still valid. Because remember, our prop can die because it has HP. Like it could be destroyed, right? So we're going to make sure we say if not platform prop dot is valid. So if it's not valid, let's just go ahead and break the loop. We don't want to keep moving our platform, okay? And then what we're going to do is we're going to say platform prop dot move to. We're going to move to the ending position. Okay, and then we're going to say platform prop. Actually, we'll just go ahead and say identity rotation here, like so. And then we're going to put in a time. Now, it's yelling at us because move to suspend your program or kind of freezes it. So we're going to put suspends right here so it'll pause and wait as needed. And now I want to move it back. We'll keep this real simple. Because 5 seconds is a long time and our prop could be destroyed, I'm going to copy and paste the is valid code here. And then we're just going to do the same exact thing again, except this time we're going to move back to the starting position. There's other ways of doing this. We're just keeping this real simple. So we're going to move back and forth and back and forth. Pretty cool, right? So here's our platform, inherits from pawn. This is pretty awesome. Okay. Let's take this to even new levels. Let me show you the power of object-oriented programming and working with these classes as we spawn some moving platforms. So let's go ahead and grab a prop asset. So we'll say at editable platform asset. Okay, this is the asset that will spawn dynamically. So creative prop asset equals default creative prop asset. We're going to save that there. What we're going to do is we're going to spawn these, okay? And then we're going to create our platform classes. So I want to create, let's say, 20 platforms. I'm going to make a new function here called, let's say, init platforms, void equals, and we'll just create 20 or so. For idx, colon equals between 1 and 20. What do we want to do? Well, we want to start at a position where we spawn it, okay? And then we need to also specify the end position of where we want these platforms to go. But we also want to make sure that we add a spacer so they're not all on top of each other. So I'm going to say start colon equals vector 3, x colon equals idx times 500.0, y colon equals idx times 500.0, and z colon equals 300.0. We'll keep the z at the same height just to make our life a little bit easier here for this demo. We're just grabbing the index of the loop and multiplying it, okay? So hypothetically, this should multiply for each prop in the index, 2 times 500, 3 times 500, and so forth, okay? And let's specify the ending position of each of these platforms. So it'll be another vector, so vector 3, x colon equals, and we'll say idx times 3000, okay? Y colon equals idx times 3000, and z colon equals 300. Keep it at the same exact height. Okay, starting position and ending position where they're moving back and forth. Now let's spawn the prop. We're going to say if spawned prop colon equals, and we'll say spawn prop. This is a built-in function in Fortnite. We're going to say platform asset, and then we're going to say start position for the starting position. And for the rotation, we're just going to say the identity rotation. All right? Now, the spawn prop is not going to give us back a prop. It's going to give us back a tuple. And so what we need to do is grab the element from the tuple. So we're going to say 0 and put the question mark right there to make sure that it's valid. You could do this in separate lines of code. I know this may seem confusing, but all we're doing is when we call spawn prop, element 0 is the prop itself, but it's an optional, and element 1 is the result. We're grabbing element 0, and we're adding the question mark to see if it's valid, and if it is, let's actually turn it into a prop. I just made it simple on one line of code here for me. You could break it out if you don't understand it. Okay, now, so we've got an actual spawned prop. Now we get to use our really cool platform that we created. So a new variable called platform of type platform. Remember, this is our class. And what are we passing into the platform? Do you remember? A platform needs a platform prop, a starting position, and an ending position. So platform prop is spawned prop, and then starting position, colon equals start, and ending position, colon equals end. So we just passed data into our class, like so, when we created it. Okay? That's it. Pretty cool. We just passed it in when we created it. Now what I can do is I can create an array up here in our game manager class. I can say platforms is an array of type platform, and we just have an empty array here right now. And then what we do is we just append this platform to the array. So set platforms plus equals, make a new array, and add the platform. This is going to add the platform to our platforms array. And I need to make sure that it's a variable with the var keyword. Now what we can do is we can initialize platforms. So again, we're creating an array, we're giving it the starting position where it spawns, array of platforms, and then the ending position is where we want it to animate to, okay? We're passing data into our function. So our game manager is just initializing things, saying, hey, let's do some stuff. But now this is where our classes manage themselves. Now I can make another method here called move all platforms. We could also have a stop function if we wanted. And what we can do is we can say for each platform in platforms, let's spawn platform.move. Okay, we're using the spawn keyword because our function, our method can suspend. So look at this. If I control click move, This is the code we wrote. We only have to call move one time in that loop, and it's gonna move all of them. We don't have to write 1,000 lines of code, and I know you've done it. I've seen you do it. I've seen other people do it. Copy and paste, copy and paste, copy and paste. Never again do you have to copy and paste, okay? So here we go, move all platforms. So we're gonna initialize the platforms, and then we're going to move all platforms. Awesome. Let's go back to the game. Build verse code. Find your creative device for lesson 8 or whatever you called it, and drag it in. Now, it's looking for a platform asset that we're going to spawn. So I'm going to type in hover and get the hover platform. I'm going to save this, and I'm going to push changes. Now check it out. We have spawned platforms, and they're moving. All from code, all from classes, object-oriented programming. Look at these things go. They're just doing their thing. And of course, you could completely change the logic to your liking for how they move, how slow they are, how fast they are, all of those things. You could do that. But I think that's pretty amazing that we didn't have to copy and paste code. We just had the code manage itself, and it's doing its thing. Okay, so again, when you want your objects in a game to do things, have them manage themselves as much as possible. Your game manager manages the whole game, kind of glues the pieces together, okay? This is like a piece of that, okay? A piece of that. So if I was creating a door that moves and opens and closes and has sound effects, I would probably create a door class with some editables and things like that, and I bring it in, and it just magically works, okay? Start breaking up your applications. Do not have a single creative device that has 1,000 lines of code that's doing 1,000 different things, all right? Now, we haven't even fully demonstrated the power of these classes just yet. Now, imagine that I want to create another class that's of type pawn. I want it to be able to take damage and heal and things like that, but I don't want it to be a platform that moves around. That doesn't make sense for this feature. So let's create a new class called pet. Equals class inherits from pawn, okay? And our pet class is going to have a name of type string. We'll make it default so you can give your pet a name. And then let's say in our case here, we want our pet to be able to animate, jump, and run. So I might have a run animation of type cinematic sequence device equals cinematic. Oh my gosh, why doesn't it autocomplete ever? Okay. All right, so I might have a run animation, and then I might have a jump animation for whenever the pet jumps, okay? And what's really cool is by inheriting from pawn, I still have health and life, and I can heal this. Like, all of that works out of the box. And then what I can do here is I can have a function called run, and we say run anim dot play, and I can have another one called jump, and we say, you know, jump anim dot play, and then so it's managing itself, and then the game manager or whoever's managing this pet can decide when to call run and when to call jump. It doesn't have to worry about the implementation details, which I think is pretty awesome. Now, here's where things get really interesting. You may be tempted, you may be really tempted, because that's all you know, to now go ahead and say, okay, at editable, let's say run animation, and you know, here you are in your game manager, and you're going to pass this in over here like this, right? Your run animation, and now you're gonna make another one for jump, like so, and you're like, okay, I'm starting to get this, so I'm gonna need those editables, and then down here, you know, I probably wanna create my new pet, so I'll say, you know, we'll call this robot, our pet's a robot, and we'll say pet, and now you're thinking, okay, well, I need to give it a name and a run animation and a jump animation, so you'd say, you know, name colon equals Larry, the robot, and jump anim colon equals, and we'll say jump anim, and run anim colon equals run anim. I named those the same thing. So you may be thinking, okay, what we'll do is we'll put the editables here in our game manager, and then we'll just pass them into our class. Pretty cool. We get some reusability there. Wrong. That is so wrong and so dumb. Don't ever do this again. I'm going to show you something that's going to change your life. Change your life as a UEFN developer. We're not doing this. What we are going to do is we are going to make our class itself at editable. At editable and at editable. Like so. And then what we're going to do, get rid of that ugly thing. What we're going to do now is create an array of editable. So we'll say at editable, and we want a bunch of pets, right? All the pets in the game. Or these could be enemies too. We're just calling it pet for right now. And I might say robots is going to be an array of type pet, like so. Now, the editable attribute is not supported for classes that are concrete. Well, that is very, very easy to fix. What we're going to do is right after the class keyword, we're going to put the word concrete. And what that's going to allow us to do is create our robots. Now check this out. I imagine in our case here, let's say this is a bad pet. We want it to do damage to other players. I'll make one more editable. We'll call this damage volume of type damage volume device equals damage volume device. Okay? Here's our pet. And so what we want to do is go back to our game. We're going to go to verse, build verse code, and let's say you have brought in some type of prop into your game, a mesh, whatever. I happen to have brought in this robot. It's a skeletal mesh that I turned into a building prop blueprint. And so what I'm going to do is drag our little cute robot here. Just drag him in. Oh, he's so adorable. And so here we go. We've got Robo over here. And I've got a folder here I've created called robots. I'm going to right click Robo and move him to robots. And now check this out. So we know that he needs a run animation and a jump animation. So we're going to say cinematic device, and we're going to call this run cinema. And I'll right click that and go to move to robots, and I will duplicate this and call this jump cinema. And then what I would do is in here I would create my sequences of the animation run and jump, and then I would change that to that sequence, and I'd change the run cinema to that sequence. Okay, so we've got these objects here. And then one more is I need a damage volume, and I'll put it here on this robot. It's way too big, so I might make this 0.2, 0.2, 0.2. Okay, and here's our little robot. And so when he runs into players, they get hurt. And we're going to call this robo damage. And I'll go ahead and right click, move to robots folder. Now check this out. We got our robot blueprint. What I'm going to do is I'm going to grab the other objects here, drag them on to this object, the robo, and so you see how I can move him around. Now here's where things get really fun. If I give it a number, robo1, and then I select the top object and the objects inside, and I alt drag, okay, now we've got robo2, robo3, etc. Okay, this is very common, and you have to do this in Fortnite game development. So here's where it gets cool though. We click our little game manager device here, and now we have robots. All right, we add 3 to the array, and we can expand it. And I realized I forgot to add the prop itself in here, so we're going to say at editable robo prop of type creative prop equals creative prop, like so. Rebuild this here, build verse code. Okay, here we go. So robo prop, we just select robo1. Run animation, robo1.run. Jump animation, robo1.jump. Damage volume, robo1.robodamage. Do the same thing for the second one. Robo prop, that's robo2. Run animation is robo2.run. Jump animation is robo2.jump. How cool is that? Now we've got some really elegant code here because those are now referenced inside of our project. Okay? So we did not have to go and copy and paste this 3 different times. I've seen the code. I see what people are doing. They will copy and paste this 3, 4, 10, 100 times and call it 1, 2, 3, 4. Don't ever do that again, okay? Make an array of your class and make your editables in there. And we have reduced hundreds of lines of code, right? And then here in your code, it's pretty awesome because what you would do is then you would just go through your robots, whatever one you want, and they could go find the player. So, you could have a function in here called move to player, right? And this robot would go do some things that are actually going to move to the player's position. And then you could even have these functions where they call them internally. If it gets to the player, do an attack animation, whatever. Your classes are managing themselves. You're inheriting properties from those classes. Pretty awesome stuff. And as you know, you can also override methods in the classes. So you can override them and do more things with them. We have only scratched the surface here for classes and inheritance and working with interfaces. But I hope this has opened up a whole new world to you of object-oriented programming, because this is how you're going to write games that scale and do amazing things. Also, this is how you can bring code to other projects. You make classes and functions and you reuse them, and then those are the things that you copy and paste, okay? Pretty awesome stuff here. That is it for now. Let's talk about the homework. Okay, here we go. Here is the assignment. You're gonna bring a custom 3D prop into UEFN for an animal or creature. Just get free ones on Sketchfab. I don't care if they're ugly. Bring a custom 3D prop into UEFN for a building, and then bring a custom 3D prop into UEFN for a vehicle. Then you're gonna create a parent class that has 3 properties needed for these various 3D objects, like we did for pawn. 3 properties or variables that apply to all those objects, okay? And then you're also gonna create 3 methods that apply for all those various objects, okay? The parent class, what is useful for all 3 of these objects? Then you're gonna create 3 subclasses, just like we did for pet, okay? 1 for the creature, 1 for the building, 1 for the vehicle. In each subclass, create 2 methods for that subclass that's unique to that class, and create 2 properties for that subclass that's unique to that class, things that would not apply to the other classes, okay? So parent class with some core features, subclasses. Do that, post a video or your exercise solution in the Discord chat room. If you didn't know, my name is Mark Wahlbeck, and you can watch the next video in this series right here. And don't forget to subscribe and click the bell so you can know when the next videos are released.